Hello friends, welcome to our channel. I hope you are all okay and doing well. You are all studying well. In our previous class, we have discussed some applications related to theorem 32 and 33. Today we are going to solve some more applications before starting the chapter 3.2. We are solving chapter 3, that is theorems related to circle, from the book Ganit Prakash of class 10, West Bengal Board of Secondary Education. So let us start solving some applications. Application 12. Which says, let us prove that a straight line can not intersect a circle at more than 2 points. So this is our question. I hope my handwriting is properly visible. Now we are going to solve it not by using theorems. We are going to solve it by using the equation of straight line and circle. Okay. The general equation of a circle is where A, B are the coordinates of the center of the circle. R is the radius of the circle, and the equation of slope intercept form of a straight line. This is basically the equation of a straight line is y equal to mx plus c, where m equal to slope of the straight line and c is the y intercept. Now this is our equation of straight line. Sorry, this is the equation of our circle and this is the equation of our straight line. Now if a straight line intersects a circle, it will okay, if a straight line intersects a circle, it will form points of intersection, and if we solve these two equations, we can get these points of equation, matlab, points of intersection. Okay, if we solve these two equations where m is a constant, c is a constant, a is a constant, b is a constant, r is a constant, if we solve these two equations, we can get the points of intersection. Now let us solve. Putting the value of y from equation 2 in equation 1, we get we are writing mx plus c in place of y. A square plus b square plus c square. This is the formula of a plus b plus c whole square. So a square plus b square plus c square 2ab minus 2bc minus uh, Okay, so this is what we are getting now. If we arrange all these terms according to the power of x, then we get this equation. So we are observing that this is a quadratic equation. Therefore, only two values of x is possible. Therefore, maximum two values of x is possible. Okay, this is a quadratic equation. That is why we can conclude there maximum two values of x is possible. For which two values of y is possible. Okay, for each value of x we will get a value of y. So two values of x, therefore two values of y. Okay, for which two values of y is possible. Therefore, let us the first value of x is x1, and if we put this value in equation 2, okay, we will get y1. Therefore, xy1 x1 y1 x2 y2. These two points of intersection is possible. Therefore, we can conclude a straight line cannot intersect a circle at more than 2 points. Now let us proceed to application 13. It says if two circles intersect each other at 2 points, Then let us prove that their two centers lie on the perpendicular bisector of their common chord. I hope this is properly visible. Let us draw the diagram. This is the first circle with center. Let us say this is x, and this is the second circle with center y, and these are the points of intersection. Let us assume this is point C and this is point D. So CD is the common chord. Okay, CD is their common chord. Okay, CD is the common chord. We have to prove that their two centers lie on the perpendicular bisector of their common chord. So let us say this is the perpendicular bisector. This is the perpendicular bisector. Okay, to prove this is given CD are points of intersection and CD is the common chord. to prove x and y lie on the perpendicular bisector of common chord CD. Construction. Let us join CX and YC. Proof. In triangle, let us call this point O. In triangle XOC, one more thing, join XC and YC and drawing perpendicular XO on XO on CD. Okay, and join OY. Okay, drawing a perpendicular XO on CD and joining OY. Proof. In triangle XOC, number 1, in triangle XOC, we can write it like this. In the circle with center O, with center X, in the circle with center X CD is a chord and XO is a perpendicular drawn to the chord CD. Okay, I hope it is clearly visible. CD is a chord and XO is a perpendicular drawn to the chord from the center. CD is a chord, chord and XO is a drawn to the chord. Therefore, XO bisects CD. Therefore, CO equal to OD. Okay. Now, in circle with center Y, therefore in circle with center Y, OY joins the midpoint of CD. Okay, OY joins the midpoint of CD. Therefore, we know a line segment joining the center and the midpoint of a chord is a perpendicular on that chord. Okay, therefore OY must be perpendicular to CD. Now we are observing that XO is the perpendicular on CD. Okay, Okay, by construction, XO is the perpendicular on CD at point O. Okay, so and OY is also a perpendicular at O on CD. Okay, therefore we know uh, only one perpendicular can be drawn at a point. Okay, so this is a perpendicular to O and this is also perpendicular to O. Okay, only one perpendicular can be drawn at a point. Therefore, XO and OY are on the same line. Okay, XO and OY are on the same line. Therefore, XY is the perpendicular bisector of the common chord CD. Therefore, XY is the perpendicular bisector of the common chord CD. Okay, therefore we can say the centers of two circles lie on the perpendicular bisector of their common chord. So we do not have space for writing, so we are writing this above, so we should write it here, but we do not have space, that is why we are writing it here. Okay, therefore the centers of two circles lie on the perpendicular bisector of their common chord. Okay, so it is proved. Okay, so I hope this question is properly clear to you. If you have any difficulty in seeing or understanding, you can write that in the comment section. I shall definitely explain that. Okay, so this is our application 13. Now let us do another application. Application 14. So Application 14 says, I prove with reason that the line joining the midpoints of two parallel chords of a circle passes through the center. Now let us try to prove it. This is a circle with center O, two parallel chords, let us say AB and CD. Okay, and similarly, this is this can also happen. Two chords are opposite side of the center. Two chords are at opposite sides. So these are the two scenarios. Now let us assume the midpoint of CD and the midpoint of AB is PQ. So given has two parallel chords AB and CD. P and Q are the midpoints of AB and CD respectively. Okay, so this is what we have. It is given. To prove the line joining P, Q will pass through O. Construction. O comma P and O comma Q are joined. Another line segment parallel to AB and CD. Another line segment, let us say MN. Another line segment MN parallel to AB and CD is drawn. Now proof. OP intersects AB at P. AOP intersects AB at P, which is the midpoint of AB. Therefore, OP must be perpendicular to AB. So this is our line MN and this is our line MN by construction. Okay, proof. So OP must be perpendicular to AB. Again, so OP must be perpendicular to AB. But MN is parallel to AB. Therefore, OP is also a perpendicular to MN. Because AB and MN are parallel. These two are parallel. That is why if this angle is 90 degree, this angle will also be 90 degree. Okay. So OP is a perpendicular to MN. Okay. OP is a perpendicular to MN. Again, OQ intersects CD at Q, which is the midpoint of CD. Therefore, OQ is perpendicular to CD. But CD is perpendicular to MN. CD is parallel to MN. Okay, CD is also parallel to MN. Therefore, OQ is perpendicular to MN. Okay, so we have OP perpendicular to MN and OQ perpendicular to MN. Okay, OP is perpendicular to MN at point O. This is perpendicular to MN at point O. But only one perpendicular can be drawn at a point. Therefore, OQ and OP are on the same line. Okay, OP and OQ are on the same line. Therefore, we can say PQ passes through the center. I hope you properly understood it. That's all for today. Tomorrow we are going to start chapter 3.2. Sorry, exercise 3.2. If you liked my video and if you are getting some benefit from my work, please like, share, and subscribe. Your support will help me to develop better contents. Thank you, friends.